asked about how maybe topology optimization of the main chassis, topology optimization of the top, chassis, topology optimization of some of these brackets that support the main servo motor. So looking at these and doing topology optimization, you need to get together as a team and decide who's going to kind of work on which part. Each team member should have a single component that is kind of their responsibility to work on and do a topology optimization. Individually, you use the component as your parametric topology optimization, reconstruction, and match property and finite element portfolio example. So at the end of this, what each of you should have is kind of illustrated by this figure. You're going to have something that does, you're not going to have the original part unless you model the original part from the components that you chose. So you could have the original design. You should show kind of the design space that you kind of chunked out, that you roughed out. And then you're going to have a topology optimization result. You're going to have a redesign that is parametric, a redesign of your part. And you're going to have then a finite element analysis, which we haven't talked about yet. But you're going to have a finite element analysis. You're going to have a mass property. So you're going to be able to say, well, the original part, I dropped on a scale and it weighed X. And through the CAD system, I did mass properties, and the new part weighs some Y value. And you should be able to compare or have a diagram very similar to this that represents your personal effort. As a team, you're going to want to take all of these portfolio pieces and you're going to want to kind of combine it into a story that you tell about your assembly. So you're going to have an assembly parametric story. You're going to have an overall assembly topology story where you could even highlight, you could say, here is one of the support frames for the servo. Here is the chassis. You could have that colored or represented by a different thing, saying we did topology optimization on these significant parts, and they would fit into your model, and you could explain that those are the parts that were re-engineered, they were remodeled, and here is the difference in the assembly mass of the whole car, and you could then verify or talk about the assembly finite element model, how much stronger or what is the strength of the lower chassis and the upper chassis when it's tied together into an assembly finite element. And collectively, this represents a portfolio example for the entire team. It's something that the entire team individually would take into a job interview for a internship or for a full-time employment. You could go in there and talk about both your individual understanding of doing topology optimization and remodeling and knowing how much time it took you to remodel, and talk about the finite element or the mass properties in respect to this part. You could also talk in terms of doing that for the overall assembly. So if you or your team had additional time, then you could consider and do other key components that would benefit, that could or would benefit from topology optimization. This will, by doing the additional parts, it would only strengthen your personal portfolio or it would enhance your team presentation. But as a minimum, what we're asking each person to do and each team to do is think in terms of doing the strategic parts that need to be looked at for topology, reduction of weight, improving performance of the overall design. So I think that's the last slide. So we have just, I think, a few minutes. Are there any questions from any of the students here at Toluca, any of the students at BYU, or any of the other remote students that are linked on? Let's maybe first take any questions from the students here at Toluca. Are there any questions that you have about this, about what's expected and what we're hoping for you to accomplish? Okay. Are there any questions from the students at BYU?
I don't think so.
Okay. What about any of the students that are linked in from Sao Paulo or from University of British Columbia or from Korea or Taiwan, if they are online? Any questions from Canada? Are there any questions from Brazil? Maybe the last comment before I end this lecture is, again, we are not trying to have you do every part on the entire car. Some of the parts are hardware parts and should not have topology optimization on them. Do we hope that you do all of the significant parts? Well, if there's adequate time, do it. But that's not been the case in previous semesters. In previous semesters, each student has one really good example that they can hold up and talk about. Some students that aren't taking a full load have time to do other parts and other topology optimization. But what we're hoping that you do is you kind of select the most strategic parts and do those. And if you have time, then work on others. Okay, with that, we will end this presentation. Good luck to each of you. And for the BYU students, I get home late Friday night, so I'll see you early next week. Have a good day.
Great, thanks.
Aren't you glad you didn't have to lecture?